Today we're going to start talking about Chapter 2. What's wrong? We'll talk later. Chapter 2. We'll talk later. Eventually, yes. Chapter 2 deals with systems of equations. Okay? Chapter 2 deals with systems of equations. It's one of my favorite things to teach. It's one of my favorite things that I get to teach. Okay? Lots and lots and lots and lots and lots of real-world applications to systems of equations. But before I can go on to show you about systems of equations, and at least for today remind you, because this is all stuff you've seen before, I need to make sure you know what systems of equations means. Like, what is a system of equations? What does that even mean? Use your context clues. Systems of equations. Multiple equations. Okay? So, system. So, tell me what you know about the circulatory system, or the skeletal system, or the digestive system. So, the skeletal system is one thing that does a job by itself. So, lots of parts that work together to do one thing, right? Okay? So, can you tell me what you think a system of equations might be? A bunch of equations that work together, okay? We're starting right now with 2. We're starting with 2 equations. How many variables do you notice in those equations? 2. An x and a y. Okay? 2 variables, 2 equations. So if I had 6 variables, how many equations would I need to solve my system? 6. That's exactly right. However many variables I need at least that many equations to solve the system. Okay? We're starting off with 2. That's not a big deal, right? So we're going to start off with 2x plus y equals 5. You can see it already on the board. They can't see it on the video, so I'm writing it for them. Okay? X minus y equals 1. There's 3 ways that I need to make sure today that you remember how to solve a system of equation. Now, understand what I'm implying here. If I'm making sure you remember how to solve them these 3 ways, you should already know them. It's just been a while since you've done them. Is that fair? So the first way that I want to solve this system is by graphing. So I gave you all a little piece of graph paper like this. What do we need on this graph paper before we can start? X and Y axis. Good. So draw me an X and Y axis. Please forgive mine. I pretend it's actually on the line. That was not too bad. X and Y. That's a Y. It's a Y. How do I graph this first equation? 2x plus y equals 5. Can I graph it in the form that it's in? Well, there's ways. It's just not the easiest way, right? Okay. So how could I get it into a form that I like? Subtract 2x from both sides. If I subtract 2x from both sides, I would get y equals negative 2x plus 5. Right? How do I graph y equals negative 2x plus 5? Is that easier to graph? Yeah, I already know my slope and I know my y-intercept. What's my y-intercept? 5. 1, 2, 3, 4, 5. It crosses the y-axis at 5, which is right there. What's my slope? Pardon? Negative 2 over 1. So from my y-intercept, I go down 2 to the right 1. Down 2 to the right 1. Now, how many of these points do I have to make in order to get the line? I only need one more after my y-intercept, right? So why did I make all the others? As a guide. It's easier to see where the line goes now, isn't it? Okay? Oh, that's not too bad. How do I graph the other one? Let's see, just a reminder, I subtracted 2x from both sides here and here. How do I graph this other one? Subtract x from both sides. So that gives me negative y equals 1 minus x. Can I graph it from there? Nope. What does it have to be? Positive y. So I've got to divide everything by negative 1. Y equals negative 1 plus x. Now, I put it that way on purpose, just so you know. Okay? Because some people don't think we can graph it in this form, because that's not exactly slope-intercept form, is it? Slope-intercept form is mx plus b. This is not mx plus b. This is like b plus mx, right? Can we still graph it from this way? Yeah, you just have to remember which one's which, right? What's my y-intercept? Negative 1. What's my slope? 1 over 1. So from my y-intercept, I go up 1 over 1. Up 1 over 1, up 1 over 1, 1 over 1, up 1 over 1. Sorry you can't see what I'm drawing. I never realized that was such a problem for left-handed people. If you're left-handed, good for you. I'm proud of you. Do I have any left-hand people in here? Awesome. 2? Very cool. No, Truett raised his hand also. Okay. So now, what? Now I've graphed both lines, because I said I want to solve this by graphing. So now what? I find the point where it crosses. Okay? The point where it crosses is the solution. It's the solution. Okay? If I say solve by graphing, this is not enough. This just shows me you know how to graph. If I say solve by graphing, you have to tell me what the solution is for me to understand that you know what you're doing. What is the solution to this system? 2, 1. Because I'm looking for the point of intersection. I'm looking for where they cross, and that point is right here. Writing the point is the solution to the system. The graph is your work. That's how you're showing your work on solving by graphing. You graph it, the answer is the 2, 1, the point of intersection. Does that make sense? Yes? All right. Will it always look like this? What are the other options that it could look like? What could happen? Okay, so they could be right next to each other. So parallel, where do parallel lines cross? So where is the solution? Nowhere. It's no solution. Oh, geez. So what's the other option? They could be 2 lines right on top of each other. One line's there. The other, whoa, pretend the 2 lines are on top of each other. Where's the solution here? So, all real. I'm glad I already taught you what that means, so I don't have to write all real out beside it. Okay, all solutions are possible. Every point that's on that line, right, is a solution. Now, so is it really all real? Is it all points possible? What are the points that are possible? On the line. So are you still okay saying all real as long as you know that it's points on the line? You okay with that? Okay. So what if so are there any questions on how to solve a system by graphing? You got it okay? So what if I said take this system, 2x plus y equals 5. That's an equal. Come on, Kingston. X minus 1. Excuse me, x minus y equals 1. So the same system, right? What if I said to solve this by substitution? What's going to happen on Friday? I'm not going to be here, right? So who's going to be here instead? A substitute, okay? So that means I'm not going to be here. There's going to be someone to substitute for me. So somebody's coming in to take my place, right? Okay? So how would we apply that same thinking to this problem? Okay? So I need to choose one of these variables to solve for. I need to isolate one variable, and I need to substitute that value into the other equation for that variable. Okay? Now in a problem like this, all of the variables are pretty easy to choose. Okay? But there are some smarter ones to choose. Okay? This one, in this particular case, is not smarter to choose because it has a multiplier. Is this one smarter to choose? Yes, it's by itself. Is this one smarter to choose? Yes, it's by itself. Is this one smarter to choose? Why is it not smarter to choose? Because it's negative. Okay? So, of these two variables, does it matter which one I choose? No, it does not. Okay? Now, for the record, when we did this problem by graphing, I already solved for this one, so I've already practiced solving for the y. So how about if when we do this substitution, let's practice solving for the x in this problem. You okay with that? So if I solve for x, what do I do to solve for x? Add y. If I add y to both sides, I get x equals 1 plus y. Why didn't I write y plus 1? Don't we always write our variable first? No, we don't have to. There's no form that we're trying to get to here, so we just have this. Okay? And now the point is, what I know, is x. I know this is what x equals, so I want to take this to the other equation and put it in right there. I'm going to rewrite the first equation, but instead of writing x, I'm going to write what I know x equals. You okay with that? So I'm going to write 2x, not x though, right? 2 times 1 plus y equals 5. See how I just rewrote that first equation, but instead of writing x, I wrote what I knew x equaled? Now what? Solve it. So distribute 2 plus 2y plus y equals 5. 2y plus y is 3y, right? Now let's get the y by itself. Subtract 2 from both sides. 3y equals 3. So y equals, try again, 1. Am I done? I'm still trying to solve this system of equations, so my answer is still going to be a what? A point. I know the y. What do I need? The x. Where should I go to find the x? How about right there? Could I go back to one of the original equations and plug it in? Absolutely. But isn't this going to be easier? X equals 1 plus 1. Now, be really careful right here. Okay? Does anyone happen to know what 1 plus 1 is? X equals 2. Is that my answer? No, it's not, because I am solving a system of equations as my answer is a point. It's a point of intersection, so I need to write my answer as a point of intersection. That is my answer. Got it? So can you solve a system of equations by graphing? Can you solve a system of equations by substitution? There's one more way I need you to know. Elimination, yes. Do you remember that? Okay, how about if I remind you? Is that okay? Now this particular problem, I'm still just doing the same exact problem because I don't want us to worry about what the answer is. I want us to worry about the way to get the answer. Is that okay? This particular problem is pretty dang easy because when we solve by elimination, what we want to do is eliminate a variable. We have become variable assassins. Am I distracting you right now with my lesson? I want to be able to combine these two equations together, add them together, and one of the variables to go away when I do that. Okay? If I combine these two equations right now, will one of the variables go away? Yes, the y will. I have a y and a negative y. If I add them together, the y will definitely go away because y and negative y is 0, right? What if, though, it wasn't this easy? Let's practice by saying, let's look at the x's. I want to eliminate the x's. If I add them together right now, will they go away? What do I need for the x's to be? I need same number, opposite sign. So if this is a 2, I need this one to be a -2. And the way that I do that is the only thing I can do to this equation that's not going to change the value of this equation is multiply the whole equation by the same number. So if I was trying to eliminate the x's in this particular problem, what would I have to multiply the entire second equation by? -2. Okay? Do you want to eliminate the x's or do you just want to go ahead and eliminate the y's? Let's do the y's, okay? So if I eliminate the y's, I'm just going to add this together. I'm going to combine these two equations. What's 2x and 1x? 3x. What's y and -y? Nothing. What's 5 and 1? So 3x equals 6. So what's x equal? X equals 2. Now how do I find y? Because I'm not done until I know y. Plug it in to one of the first two equations. Doesn't matter which one. Which one do you think is easier? So some people think the first one's easier because y is by itself and is positive. Some people think the second one's easier because x is by itself but y is negative. It doesn't matter. It really doesn't. If you've done this correctly, it does not matter which one you choose. I heard the first one first, so I'm going to put it into the first one. So 2 times 2 plus y equals 5. So 4 plus y equals 5. So y equals 1, which we already knew, right? Is that the answer? No, what's the answer? It is a point of intersection. Okay, it is a point of intersection. We're always going to write, when we're doing problems like this, always going to write our answer as a point of intersection. You okay with that? Any questions?